We are continuing with our vector, and in our last video we talked about how to resolve or find the resultant of two or more vectors when the two vectors are moving in the same direction and when they are moving in opposite direction. So today we are going to continue with the other three cases that are remaining, which is the third case is when the two vectors are at right angle to each other. So case 3. This. Now, if they are acting at right angle to each other, at which theta is equal to 90 degrees, it means that we have our object here, and the force, one force is acting towards this, and another is acting perpendicular to it. So let us assume that both of them are acting at 90 degrees to each other. So let's give this magnitude 30 Newton. Vector, and let this be 40 Newton vector. Now the question is, how do we resolve this? How do we find the resultant of this particular vector case? Now, to find the resultant, we use what we call the parallelogram law of forces or vectors. Now, parallelogram law of vectors states that if two vectors are represented in magnitude and direction by the adjacent sides of a parallelogram, the resultant vector is the diagonal of the parallelogram drawn from a common point. Now, what does this mean? If a parallelogram is any four-sided shape, is a parallelogram, so a square is a parallelogram, rectangle is a parallelogram, trapezium is a parallelogram, which means this can be formed into a parallelogram. Now, which means if we have 30, yes, so if this is now a parallelogram, then they said that the resultant vector is the diagonal. What is diagonal? A diagonal is a line that divides a shape into two equal parts. So we have to draw a diagonal here. It means that this diagonal is the resultant force. Now the question now is, how do we now find this diagonal, which is now representing the resultant force? Now we can use two methods to solve this. We can use the scale method and we can use the analytical method. So first of all, let's use the scale method to solve this. Now, using the scale method, take your ruler and take your protractor. Then come and measure this thing up to scale. First of all, you choose a scale. And what will be your scale? Remember that there's no 30 Newton, there's no 40 Newton in your ruler. So what you first of all do is to convert these into centimeters. And how do you do? By choosing a scale. So you can say that let 1 cm on your ruler represent 10 Newton on the board. So which means every 1 cm will represent 10 Newton. If it means you want to draw 30 Newton, you should be drawing 3 centimeters. And if you want to draw 40 Newton, you should be drawing 4 centimeters. So let us draw that. So let's assume that you are drawing on your own now. First of all, draw a very clear horizontal line. On that line, measure out just put a point here. Start putting the point, put your protractor. You must always use protractor for your line to be straight. So put your protractor at this point. Then mark out your 90 degrees on the protractor. After marking it out, you can now use a ruler to draw this line to meet with this line you have, this point you have drawn. Then on this line, mark out your 3 centimeters. Mark out your 3 centimeters and put your arrow. On this line as well, mark out your 4 centimeters and put your arrow. So let's assume this is your 4 centimeters, put your arrow here. So this is 3 cm and this is 4 cm. So after doing that, next on the board, you can also, at this point, you mark out your 4 cm, put your protractor there, then mark out a point, also 90 degrees. After marking out the 90 degrees, then draw a dotted line to join this together. Then on that dotted line, mark out 3 centimeters. So mark out 3 centimeters here, and then also join this one with a dotted line to meet with this. Now you have completed your parallelogram. Then use your ruler to join this point and this point together. So you join this and this together. This becomes your resultant vector. So what you do to get this resultant vector, just measure it with your ruler. whatever you get, it's your answer. So let's assume at the end of the day, after measuring this place, you got 5 centimeters, for example. So let's say at the end of the arrow there gave you 5 centimeters. Okay. After getting it, you can now come and say convert it into Newton. So you can also come and say arrow therefore is equal to 5 times 10. Remember, you assumed 1 cm to be 10 Newton. So which means 5 cm would be 5 times 10, which will give us 50 Newton now. So you have converted it into 50 Newton. It has to be more than this force because this resultant vector is longer compared to these two. So it has to be, the magnitude has to be bigger. Now, after doing that, remember, in everything we have been doing, we have been talking about the resultant vector and as well the direction. So how do you find the direction here? The direction here is the angle that the resultant vector makes with the horizontal vector. This is the horizontal vector here. So the angle that the resultant vector, which is this, makes with the horizontal vector is your direction. So what you do is put your protractor here back. Then here is your 0 point of the protractor. Read it upward. Find out the value of the protractor of the angle at this point where this resultant line is. That becomes your answer. So that might give you alpha is equal to 30 something, either 35 degrees or 37 or 36 degrees. That is your answer. So you can practice it yourself and get the real answer. So if you are using the analytical method, you don't need to draw all these. You draw all this because you are using the scale method. So let us draw back our line, and this is our 30 Newton. This is our 40 Newton. So you just use your dotted line to join this together to form it a parallelogram, and then join this together. So this becomes your arrow. Don't forget to put your arrow here. So you use, since now, if you check very well, this is a right angle triangle, this is a right angle triangle. So pick one right angle triangle. So I'm picking this. So this is my right angle triangle at this point. Yes, so here we have, this is our arrow, don't forget that, and this is our 40 Newton, which makes this side 30 Newton as well. So this is right angle triangle. Remember the formula to use when you are looking for sides of a right angle triangle. Use Pythagoras theorem. Pythagoras theorem, you have hypotenuse squared is equal to opposite squared plus adjacent squared. So you have arrow squared is equal to 40 squared plus 30 squared. So that gives us arrow squared is equal to 1600 plus 900, and that gives us arrow squared is equal to 2500. So arrow will now be equal to the square root of 2500. That gives us 50. So arrow then is equal to 50 Newton. Remember, what you have here when you do the scale method must almost be the same thing, if not the same, as what you also have in your analytical method. Must also be the same. Then next is the direction for the resultant vector. So direction is also always here. Don't forget, here is your direction, alpha. Now, how do we find our alpha? So your alpha now becomes opposite over adjacent. So we have opposite over adjacent. Trig ratio for opposite over adjacent is tan. So we have tan alpha is equal to opposite over adjacent, which gives you tan alpha is equal to, opposite here is 30 Newton, adjacent here is 40 Newton. So alpha is equal to tan inverse of 3 over 4, or 0 will cancel out 0. So alpha will be equal to 37 degrees answer. So you see, almost the same thing as what we have. Thank you very much. Please do well to subscribe to this YouTube channel and then be getting more lessons.